Environmental DNA is everywhere. If you go into Starbucks, you sit down to have a coffee, we could probably take a cotton swab, swipe it on the table, take it back to the lab, extract the DNA. You'll probably have DNA from anyone who's touched that table that day. There's a good chance, maybe even a couple of days. Maybe someone had their dog in. You will also get that in there. The same principle applies when we're dealing with an aquatic water system. Zebra mussel is a pretty small little bivalve. It's about that big. It looks quite similar to a clam. The reason why it's such a dangerous species to local habitat is its ability to outcompete local species. It was obviously going to affect species in the water, but then it also affects birds that come and predate these and eat these. Anything in the water that they can swarm to, they'll form a dense colony around. It could be rock, it could be any trees or vegetation in the water, or it could even be boats. We know we've got DNA in there, but we don't know what DNA we've got in there. So what we want to do is develop a method for detecting this species without having to have a visual confirmation. So we could go to a site, take multiple samples of water, maybe about 50 mils, take them back to the lab, and what we'll be able to do is strip it down, we'll extract that DNA, and we'll probably get into a small vial, and we will know, do we have that species present or not. Everything in an ecosystem is there for a reason. So when you get an outside factor thrown in, it is quite difficult to know how is it going to affect. You can look at an ecosystem as a card pyramid. Each card is supporting something on top of it. But if you don't know what each card is supporting, removing one card, it may not do anything because it's at the top, or it may cause the entire ecosystem to collapse because it's at the bottom. And the addition of a new species to an ecosystem can have huge impacts.